Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present experiment 3, Major Losses in Pipe. Our respected lecturer is Dr. Muhammad Arif Abdul Aziz. The date of the experiment is 11 April 2021. We are from Group 7. Our group member is Muhammad Danish Fahmi bin Azhar, Eng Zinlei, Nur Arina Izzati binti Sulaiman, and Lim Zin Yan. Now, I will present on the introduction. Major losses. For an incompressible fluid through a pipe, there is always a creation of a friction force along the pipe wall against the fluid. In this experiment, the theory used is the loss of energy and the total head of fluid due to the frictional resistance of real or viscous fluid. In the fully developed straight pipe flow, energy loss or head losses occurs due to the wall friction. This kind of losses are categorized as the major head losses with the Reynolds number is greater than 2300. There are 4 factors that we need to consider in calculating this total head loss, which are the velocity of the fluid, length of the pipe, the roughness of the inner wall of the pipe, and the inner diameter of the pipe. Next, the objective of this experiment is to determine the pipe friction factor and the resistance coefficient. Furthermore, I will also present about theory of this experiment 3. In theory, generally, for turbulent pipe flow, the Reynolds number lays between 4,000 to 5 million between 2 points of the horizontal pipe. We also can calculate the pressure loss P and the major head loss experimentally by using the Bernoulli equation. For the pressure loss, P is equal to pressure loss between 2 points equal to the friction coefficient over inner diameter times with the density of the flowing medium, and V square is the square of the speed of the flowing medium. For the major head loss, HL is equal to friction coefficient times with the square of the speed of the flowing medium over the inner diameter and also the gravity constant times 2. Next is the calculation of the friction coefficient. The first formula is by using Moody's chart. For the turbulent pipe flow, the pipe friction coefficient depends on the equivalent pipe roughness and the Reynolds number. An example of the equivalent roughness is based on the types of pipe listed in this table. We can obtain the friction coefficient by using Moody's chart because Moody's chart summarize the relationship between the Reynolds number, the friction coefficient, the equivalent roughness for the pipe, and the inner diameter of the pipe. For the Reynolds number calculation, we need the velocity of the fluid, the inner diameter, and the kinematic viscosity of the fluid, where we can obtain the kinematic viscosity based on its temperature from this table. The speed of the flowing medium can be obtained by using this formula. There are also 3 other formulas that we can use in calculating the friction coefficient. The first one is the Blasius formula, Colebrook formula, and lastly the Moody formula.
I'm Sinlei, and now I will introduce about the methodology of this experiment. First, I will explain about the apparatus and materials of this experiment. We will use pressure-meter, 22 mm, 62 mm, differential pressure sensor, digital displays for pressure, pump switch, main switch, electronic pressure sensor, return hose, return valve, interchangeable measuring objects, water tank, drain valve, pump, various measuring sections, feeding hose, gate valve, thermometer, and we will use 3 types of pipe for this experiment: steel, copper, and PVC. And also we will use water for this experiment. Next, I will explain about the procedure of this experiment. First, connect the feeding and return hose to the tested pipe section. Connect the manometer tubes at one of the 2 tube manometer, H1 for inlet and H2 for outlet to the tested pipe section. Turn on the main switch and the pump. Slowly open the gate valve until the reading of rotameter reach 2 m³ per hour. Open the ventilation valve, black color, on top of the 2 tube manometer and let the water to overflow from the system. Close the gate valve and the pump. Slowly open the ventilation valve, which is white color, on top of the 2 tube manometer until the preset minimum reading of 2 tube manometer. Slowly open the gate valve until the level of water at 2 tube manometer of H1 reach the maximum and H2 reach the minimum. First reading is recorded. Reduce the reading of rotameter to 5 different values by adjusting the opening of the gate valve. Transfer the manometer tubes at a 2 tube manometer to the differential pressure sensor, P1 for inlet and P2 for outlet. Adjust the value of flow meter to the previous reading. Record the reading of differential pressure sensor which at digital display of pressure. Next, reduce the reading of rotameter to 5 different values by adjusting the opening of the gate valve, same as before. After all the readings are taken, close the gate valve and the pump. Change the feeding and return the hose to another pipe section. Repeat the same procedure for other pipe.
So here we are going to discuss about method of calculating all the data given during experiment of major losses, which is experiment 3. So first of all, to calculate the coefficient of friction for each pipe, first we need to determine the value of Q, which is we show to you how we calculate for pipe galvanized. So for pipe galvanized, Q is we take the data for the first flow rate, which is 0.8 meter cube per hour. We times to we convert it into meter cube per second, so we get 2.22 times 10 power of negative 4 meter cube per second. And then we calculate the velocity. So the formula of velocity is 4Q divided by 4D squared. So we just insert all the data that we get, which is Q we get from above equation. So the answer we get is 1.7542 meter per second. And then by 2 equation above, we can calculate the Reynolds number. The Reynolds number equation is velocity times diameter over the viscosity. So we just insert the answer from equation above and the viscosity from the table into the equation. So we get the Reynolds number is 29,115.1427. Next, to calculate the coefficient of friction, there are 4 methods, which is Modichart, Blashes formula, Colebrook formula, and Moody formula. So from Moody chart, we need to find the roughness, which is E over D, and then we get 0.01181, and then we from the chart we read and compare it with Reynolds number, and we get coefficient of friction, which is F equal to 0.0545. Next, we move on to the Blashes formula. So for the Blashes formula, coefficient of friction is equal to 0.316 over Reynolds number power of 1/4. So we get the answer for coefficient of friction by using Blashes formula is 0.0242. And then we move on to the Colebrook formula. So for the Colebrook formula is, the equation is 1/f equal to -2 logs E over D over 3.7 plus 2.51 over Reynolds number times square root F. So the coefficient of friction we get is 0.0427. And then lastly, we can calculate the coefficient of friction by using Moody formula, which is 0.01375 times 1 plus 200 times E over D plus times power of 6 over Reynolds number, and then all inside the bracket is power with 1/3, and then we get the coefficient of friction is 0.054. And then this is we show you the graph in change in delta H versus the flow meter. So this is the graph. We tabulated all the data in the graph, so it is easier for us to see the relationship between each other. So next is the graph of coefficient of friction versus Reynolds number for the pipe galvanized. From the equation above, we calculate with all the data given to us, and then we get this type of graph. Moving on to the next part is the graph coefficient of friction versus Reynolds number for copper pipe. And then this is the tabulated of the data that we get. Next is the coefficient of friction versus Reynolds number for PVC pipe with diameter 20 mm. The relationship for each graph will be discussed in the next part, which is discussion. And then moving on to the coefficient of friction versus Reynolds number for PVC pipe with diameter 16 mm. And then lastly, the graph we get is for PVC pipe with diameter 32 mm. Thank you.
I am Sinian, and I'm going to talk about discussion. From the graph, we can see that when the volumetric flow rate of the water in the pipe increases, the differences in height of the manometer also increase. This is because when the fluid flows through a pipe with small cross-sectional area, the velocity of a fluid will increase and the pressure will decrease, which is stated in Bernoulli's principle. These graphs show that the coefficient of friction for each pipe calculated by Colebrook formula, Blasier's formula, and Moody chart are slightly different. Blasier's formula is simpler compared to the Colebrook formula, as it only links Reynolds number for calculation, while Colebrook formula is very complicated, as it involves the data for diameter of the pipe, roughness, and also the Reynolds number. From the graph, we can say that Blasier's formula is only suitable to be used in smooth pipe calculation, and it is less precise for high roughness pipe. So, Blasier's formula is not suitable to be used in determining the coefficient of friction for galvanized steel pipe with roughness of 0.15 mm compared to other formulas, due to the low roughness of copper and PVC pipe. The coefficient of friction determined by Blasius's formula is more likely the same as the results calculated by other formulas. The coefficient of friction for the pipes using Colebrook formula and Moody graph are appropriate among all the formulas as it does not show big difference on the data. However, the coefficient of friction calculated using Moody's formula has big difference compared to others, which might be caused by some errors. The PVC pipe 32 times 1.9 mm has the lowest head loss because the increases of diameter of the pipe with the negligible roughness causes the flow area of the pipe to increase. Thus, the velocity of the fluid is reduced and a lower head loss occurs due to the friction in the pipe. Errors and precautions. We can avoid parallax error by placing our eyes perpendicular to the reading scale. We must make sure no presence of air bubbles in tube before experiment to prevent inaccuracy of data. The fluctuated reading of manometer can be overcome by taking the average value from several readings. We must ensure the rubber tube is connected tightly with the valve to prevent leakage of fluid.
Next, we will present on the last part, which is the conclusion. For the conclusion, along the experiment, the friction coefficient is determined or calculated by using various formulas such as Moody's chart, Moody's formula, Colebrook formula, and the Blasius formula. For this experiment, the roughness of inner pipe wall of galvanized steel pipe is the highest, followed by the copper pipe, and the lastly is the PVC pipe. Moreover, the galvanized steel pipe has the smallest diameter with 12.7 mm and resulted in the highest value of the friction coefficient, while the PVC pipe contained the largest diameter 32 mm and resulted in the lowest value of the friction coefficient. The data obtained may not be accurately the same with the theoretical value due to the presence of error throughout the experiment as discussed during the discussion part. These are the reference used in our experiment 3. That's all from us. Thank you.